Hi guys, welcome to another tutorial. In this tutorial, I'm going to talk about pretty much everything that you might need to know when you try to calculate spatial statistics or zonal statistics of a particular raster based on some given polygon boundaries. And we are going to use Python to do that. But before proceeding into the tutorial, I would like to give you some insight to the data that we are going to use. Now, I'm going to use QGIS for a moment just so that I can quickly visualize the data. I'm going to use rainfall data actually to perform this spatial statistics calculation. Now, these rainfall data are actually CHIRPS gridded satellite rainfall data, and I have downloaded a cluster which falls on Portugal. So I'm going to use Portugal as my example today for this tutorial, and you can see that I have downloaded this particular data which corresponds to 15th of April 2020, and I have a shapefile which corresponds to the districts of Portugal. So what I'm going to do today is to calculate let's say the average rainfall which has fallen on this particular day over each of these districts. So what we do is we are going to sort of take the average of all the pixels which falls within each of these districts, and we are going to use Python in order to do that. And this is just for one raster. Now, if I show you some additional data which I have over here, you can see that I do have the rasters actually starting from the 1st of April all the way up to the 30th of April. Now, we might be able to actually perform some other statistical calculation based on all of these data as well. But for the first part of this tutorial, let's focus only about calculating the spatial statistics just for one raster. And later on, maybe in the second part of the tutorial, I might show you how to deal with this kind of a higher number of rasters, so that actually you maybe sort of extract all the data from all the rasters and perform some sort of advanced statistical calculation which takes into account time series data as well. Alright, so to get started, first I'm going to minimize this QGIS window because we won't be using QGIS actually for this. We will be using Python. Now if I go to my file explorer, you can see over here I have the rainfall data rasters over here, and I do have the shapefile which corresponds to the districts of Portugal. So for this tutorial you're going to need a couple of libraries. You're going to need the GeoPandas library, and you're going to also need the raster.io library. If you do not know how to install these libraries, I have created tutorials for each of them. And in addition to those two, you also will need another library called rasterstats. Now, if you haven't installed rasterstats, it's quite easy. As you can see over here, you can just do a simple pip install rasterstats installation. What you can do is you can go to your Anaconda prompt, right click and run it as the administrator. And from there, you can simply just copy this and right click over here and you can paste it, and when you hit enter it'll get installed. Now you can see that the requirement has already been satisfied because I have already installed this particular library. But if in your case, if you haven't done so, just go ahead and install this one first. It's going to take a couple of minutes. That's it. So let's go ahead and import these three libraries first. I'm going to first import GeoPandas, and then I'm going to import raster.io, and after that I'm going to import rasterstats, these three libraries. We can just run this one and make sure that we do have all the libraries imported without any issue. And next what I can do is I can read in the districts shapefile. So you can simply read a shapefile using the GeoPandas library by saying, let's say I'm going to call this as districts. That's going to be equal to gpd.read file. And over here you can specify the path basically to this folder, and the name of the shapefile is districts.shp. Alright, now you can run this. And if you want to have do a quick visualization, you can say districts.plot, and that will plot out the districts for you, as you can see over here. Alright, now next, let's go ahead and import the rainfall raster which we selected. Now, as you can see, if you can recall, you can see that I have actually about 30 rasters over here. I'm just going to select one date, maybe let's say 15th of April. And I'm going to do the spatial statistics calculation for this particular raster first. So we can use the raster.io library to read in this raster. Alright, I can call this as maybe, let's say RF. That's going to be equal to raster.io.open. And similar to what we did before, we specify just the path to that particular file, and I'm going to specify the file name over here, which is going to be (2024-15.tif), and over here we also can specify the mode, which is reading. And now we can run this. Alright, now if you would like to do a quick visualization of this rainfall raster, what you can do is you can simply go ahead and say from raster.io.plot import show, and from here what I'm going to do is let's go ahead and run this first. Yeah, and after that you can just say, now since we have imported this show over here, you can just say show and specify the raster which you imported, which is this rainfall raster, which is RF. And now you can see that we actually managed to do a quick plot of the raster itself as well. Now before going into the zonal statistics part, let me just take a couple of minutes to actually show you how to, maybe in case if you would like to plot this shapefile on top of this raster, you can even actually do that quite easily. Let me just go ahead and show you that one as well. Let's say plotting the raster and the shapefile together. Alright, so for this what you can do is first you have to actually import another library, which is the matplotlib library. I'm going to import it as plt, and after you have done that, let's just go ahead and run this first. And now what you can do is you can simply say figure, and then you have to define an axis, and that's going to be equal to plt dot, plt is what you imported from here, plt dot subplots. And over here I can just put 1 by 1 because we are just going to have one subplot. In case if you happen to have maybe 2 or 3 subplots, you can actually specify that over here. But in this case, in my case, I'm just going to have one subplot. And just think of this as sort of creating the platform for you to plot your graphs on, something like that. You can just imagine that in that kind of a way. Since you imported this show over here, you can just say show this RF raster, but over here I'm going to say the axis on which I would like to show this RF raster is basically this AX that I defined over here. And maybe I can specify a title. Maybe I can say title equals rainfall. Alright, this one is corresponding to the raster. And next what we can do is we can also go ahead and plot the shapefile which we imported over here. And normally the way that we would plot a shapefile is the name of the shapefile dot plot. Now within these brackets you have to specify the axis on which you would like to plot, and as you might have guessed by now, we are going to plot this on the same axis as this, so that's why I'm going to specify this axis to be the same as the AX value over here. Alright, now we'll add one more argument, plt.show, and after that you can go ahead and run this. And as you can see over here, even though it's not that clear, you can see that the shapefile now has been plotted on top of the raster. Now we can do a couple of amendments actually to make this more visually pleasing. Now one thing what you can do is you can actually get rid of this fill color, and you can just only have the boundaries of the shapefile, of the district shapefile. Now to do that you can pass one argument to this. You can say the face color equals none, and at the same time you better define an edge color. So edge color would basically be the boundaries, the colors of the lines which specifies the boundaries of the districts. And by looking at the color of this raster, I think it's better to maybe assign a color like yellow so that it'll be a bit more obvious. And apart from that, I think I'm good to go. So let's go ahead and run this. Yeah, now you can see that we managed to plot the district shapefile on top of this rainfall raster. Now if you need to increase the figure size, you can actually do that as well. You can pass one argument over here called fig size. Now just keep in mind that you're passing this figure size argument to this main platform which you created, on which you're actually adding more plots. Now just think that you have another shapefile which you need to add. What you can do is you can actually specify that second shapefile over here as well, and then when you specify the a-axis to be equal to this axis, it's going to get plotted on top of this one. So that's how basically that works. So as I said, you can specify maybe the figure size to be 10. Maybe I can add the figure 10 by 10 figure size, and let's try to plot this one and see how it looks. Yeah, it's a bit larger than I expected, but yeah, I think now you get the idea. You can see clearly the boundaries, the district boundaries, and you sort of have an idea how the spatial variation of the rainfall actually happens around this area. Alright, I'm going to put this back to the default mode, in which the figure size will be not specified by me. Alright, now if you would like to also have some idea about the raster values of this particular raster, you can even create a histogram. Now let's say if I want to create a histogram right beside this graph, right beside this map, actually that's possible, because now over here we are using subplots. Now instead of using 1 by 1 subplot, I'm going to use a 1 by 2 subplot, which actually opens up a whole new area for me to sort of add some more things, add some more information, or even add a completely different map. In addition to this show, I'm also going to import one more thing over here from raster io.plot. I'm going to import showHist. Basically what this showHist does is it's actually showing the histogram of a particular raster that we are going to assign for it. If you would like to add in another figure over here, what you can do is you can actually specify two axes. Let's say I'm going to call this one as axis 1 and another one as axis 2. And this is how you would specify that. And I'm going to put this axis 1 to be the axis of the main rainfall raster and the district shapefile. Now if I plot this one, you will see that it actually opens up some area for another map, in which I'm going to sort of embed the histogram. If you want to plot the histogram, what you can do is, since we already imported this showHist over here, you can say show histogram, and I'm going to call for the histogram of the rainfall raster. And I can even specify a title. Let's say I would write histogram over here. And now I'm going to specify the axis, and in this case I'm going to specify the axis as AX2, which is actually corresponding to this empty space. And in this case, maybe let me also go ahead and specify a figure size, something like maybe 10 by 4. Alright, now let's run this one and see how it looks. Yeah, now you can see that we have the rainfall raster over here. On top of that, we have the district boundaries. And over here, we have the histogram. So this histogram basically gives you some ideas about the pixel values, the density of the pixel values. And also you can see that when it comes to higher rainfall values, such as, let's say, somewhere over here around 70 something, you can see that the histogram shows that the frequency of that kind of value is actually quite less. So that's how you basically interpret the histogram. Before you move into any further analysis, it's actually a good way to sort of get a hang of the overall data. Sort of a summary, but something to give you a bit of a perspective of the distribution of the data. All right, now let's go into the calculation of the spatial statistics part. Alright, now what you have to do is first you have to create a NumPy array based on this imported rainfall DEM. Now if you go to the variables explorer, if you go to the IPython console over here, and if you try to check the type of this rainfall raster which you imported, you will see that it's actually not a NumPy array by itself. So we can actually assign the values into a NumPy array. So what I can do is I can say assign Alright, I'm going to name the variable as rainfall array, and that array is going to be equal to rf.read, and I put 1 over here, and if I run this and I can go to the variables explorer, you can see that we have one variable called rainfall array, and you can see a bunch of numbers like -9999, and if I scroll down over here, you will see that you eventually actually start seeing real numbers. You see a bunch of zeros over here, and along with that you can see some values which actually looks like legitimate rainfall values. So just believe it or not, these are actually rainfall values which corresponds to each raster pixel. So we sort of extracted the pixel values from using the raster.io library, and we throw it into an ND array over here. So that's what this is. And if you would like to quickly check the type, you can even check the type of this rainfall array variable, and it will tell you that it's a NumPy ND array. Alright, next thing that you need to know is to acquire the values corresponding to the affine. Now I can create a variable called affine, and that's going to be equal to rainfall.transform. Now where does this come from? Alright, now if I go over here and this one is rf.transform. Now if I would like to get some metadata of this rainfall raster which I imported over here, I can just say rf.meta, and you see a couple of things over here which gets appeared, like the data type which is float32, the no data value which gets assigned for every pixel which actually doesn't have any data is -9999.0, and the width and the height is given over here. The coordinate reference system EPSG 4326, that's the WGS 1984 geographical coordinate reference system, and over here you see one key called transform, and this transform has these affine values which basically, if you're not familiar with this, each of these 6 values actually corresponds to certain things. For example, this first number corresponds to the width of each pixel, and this second number corresponds to the row rotation. Typically it's a 0 value, and this third number which corresponds to the x coordinate of the upper left corner of the upper left pixel, and this value basically corresponds to the column rotation, which is also typically a 0, and this value again corresponds to the height of the pixel, and this value corresponds to the y coordinate of the upper left corner of the upper left pixel. So if you would like to acquire a certain type of a data, let's say you would like to have some idea about the no data values, what you can simply say is you can say rf.nodata, and that will give you the value which has been assigned for the no data. Similarly, if you would like to know the CRS, you can say rf.crs, and that will show you actually which coordinate reference system this particular raster is in. And similarly, what you can do is you can say rf.transform, and that will give you this affine set of values. Now this is the same thing that I'm actually going to save into a variable called affine, and as you can see over here, just going to paste it over here, because when we use the raster stats library, we will need these 2 variables in addition to a couple of more variables. So that's why I'm going to make these 2 ready first. Alright, now I can first go ahead and run, and then I can say calculating the zonal statistics. Alright, the way to calculate the zonal statistics would be to use this raster stats library which we imported, and we can use that. Let's say I'm going to specify a variable. Let's say I'm going to calculate the mean, the average rainfall over each district for this particular day. So I'm going to create a variable called average rf, which is average rainfall, and that's going to be equal to raster stats dot zonal stats, as you can see over here. Now over here we are going to specify a couple of arguments. So the first argument that I'm going to specify is the shapefile which I imported, which is the district shapefile, as you can see over here. And then I'm going to specify the numpy nd array, which is this rainfall array. And if you specify that numpy nd array, it's important to specify the affine as well. And this affine is going to be equal to this affine variable that we recorded over there. And over here you can specify which statistics you would like to have. In my case, I would like to have the mean, but let's say if you would like to have other things such as the minimum value and the maximum value, you actually can specify all of those here, and it will produce all of these statistics for you guys in case if you need. But for my case, I'm just going to stick to just the average values. And over here I'm going to specify one more argument, which is called GeoJSON out, which is equal to true. For the time being, let's go ahead and run this. Alright, now I can open the variables explorer, and you can see that I have some values in this average rainfall variable. Alright, now if I open this average rainfall list, you can see that we have a couple of entries. Actually, we have multiple entries corresponding to 18 districts. And if I go ahead and open one of these entries over here, you can see that under properties, it shows you the name of the district along with the average rainfall value for that particular district on that given day. Similarly, I can go ahead and open another district, let's say this, and under properties, you can see that it shows you the average rainfall, the average of all the pixels summed together and divided by the number of pixels. The value accounts to 0.5819, as you can see over here. So this is basically how you calculate the zonal statistics. Now if you put max over here, it'll actually, instead of taking the mean, so in that case this has to be max rainfall. And if I open this max rainfall variable over here, you can see that now for each district the max rainfall is like this. And if I scroll and go to another district, you can see now over here the maximum rainfall is 56.27. So I guess you get the main idea. I'm going to flip this back to mean, and over here it should be the average rainfall. Alright, now you can see that this list itself can be a bit messy with all sorts of information that we might not necessarily need. So let's see a way to actually pull out this data, pull out the data that we need from all of this information that's going on over here. Now there could be multiple ways of doing that. So I'm going to actually use a while loop in order to extract the data. So let's say I'm going to put a comment saying that extracting the average rainfall data from the list. Alright. So I'm going to create an empty list. So let me go ahead and name this empty list as average rainfall. And you can specify an empty list by just passing 2 square brackets. And since I'm using a while loop, I need to have a counter. So I'm going to define another variable called I, and I'm going to assign a value of 0 for that I value. Let's go ahead and write the while loop. Now I'm going to let this loop run while the value of I is less than the total size of this average rainfall list. Now if you want to know the size of this average rainfall list, what I can say is I can say length avg rf, and that's going to tell you that it actually has a length of 18. So let's go ahead and assign this to run as long as the value of I is less than 18. And I'm going to say that take the average rainfall empty list and append. What do you need to append? You have to append the average rainfall over here, and I'm going to put the I value which I specified over here. And since this is a Python dictionary, I'm going to explain to you guys this statement, this piece of code that I'm going to write over here. But for a second, just bear with me. I'm going to specify an argument called properties. Alright, now let's talk about this part. So if I say average rainfall over here, it's actually going to be a huge list with a bunch of numbers. You can actually check the type of the average rainfall and it'll tell you that it's a list. Alright, so the way to specify each argument of the list is by passing the index. If I say average rainfall 0, it's actually going to return to me all the information which corresponds to the 0th index. And if I open this average rainfall variable from here, and you can see that all the information that's embedded in this list are actually dictionaries. The way to extract data from a Python dictionary is by specifying the keyword that you see over here. This is basically something like a column heading, but it's just another data structure in Python which is called the dictionary. So you have to specify the keys of the dictionary, in this case which happens to be the properties, because the information that I need is under this keyword called properties. So that's why I'm going to specify over here average rainfall 0 and over here properties. And that's basically going to return me the name of the district. You can see the name is a bit distorted because of the characters, because of the Portuguese characters, but I'm not going to care about that much. Maybe let me go ahead and select another one. Yeah, you can see that it's actually retrieving exactly what I need, the name of the district and the mean temperature, the mean rainfall value. So during each iteration, this will start from the value I being 0, and over here during the first iteration the value of I will be 0, and during the next iteration I would like the value of I to be 1. So I'm going to tell that after you record this particular line which corresponds to the 0th index, increase the value of I by 1 unit. You can say that by saying I equals I plus 1. Now in a pure mathematical sense, actually this doesn't make any sense because you cancel out the i's and it basically equals nothing equals to 1. But if you are new to programming, this is actually the way to specify the variables which you would like to increase during each iteration. Alright, so what we can do is we can just go ahead and run this. And now if I check this average rainfall empty list, which happens to be which was an empty list at this stage, it's actually not an empty list anymore. If I open this, you can see that we actually extracted perfectly just the information that we need. It's not messy anymore, but you can see that each element of the list is actually a dictionary. I think this is good enough for us. You can see now each district and its mean temperature value, but if you would like to make this a bit more presentable, you can even convert this directly into a pandas data frame. Now if you want to convert that into a pandas data frame, you can go ahead and import pandas library as, let's say, pd, and I can say that transferring the information from the list to a pandas data frame. Right, this one is quite easy. You can just create another variable called, let's say, average rainfall of Portugal, and that's going to be equal to pd dot data frame. And what you have to do is simply pass this average rainfall list over here. You don't have to do anything else. And once you run this, and if you say print average rainfall Portugal over here, and when you run this one, you will see that now this one gets printed out, and in this column you see the name of the district, and over here you get to see the average rainfall of each district. And if you would like to do a quick visualization, you can even do that. You can just say average rainfall of Portugal dot plot, and you can specify the column names. In this case, I would like to have the name of the district as the X column name. So in that case, the name of the column is name 1 for some reason, and the Y axis is going to have what? This mean. And the type of the chart, I would like to have a bar chart instead of a line graph. and the kind you can specify as bar. And from here you can see basically the average rainfall values corresponding to the 15th of April. Well, it would be nice to add a title as well. Let's say average rainfall on 2020 April 15th, something like that. Yeah, that's about it. So you can see that we sort of managed to grab the data from the raster and take the averages for each district, and we managed to plot it out like this. Now you can obviously make the tweaks to make this graph look much more presentable, but I guess this was something additional that you got to learn through this tutorial. Because our main objective was sort of to teach you how to extract, how to sort of get the spatial averages, the zonal statistics based on a given polygon boundary. In this case, it happens to be the boundaries of each district of Portugal. Alright, so I guess you learned something new. If you did, and if you did like this tutorial, you show your support by hitting the thumbs up button, and also you can share this tutorial with your friends. And if you haven't subscribed to this channel yet, kindly consider subscribing, because you'll get to see this kind of interesting and helpful tutorials, I believe, to many of you guys. And in the second part of this tutorial, I'll teach you how to deal with a number of rasters, as I showed you guys before, because right now we did this analysis only for this raster which corresponds to the 15th of April, but in the next tutorial I'll show you how to sort of do a further statistical analysis for time series data, because we have data starting from 1st of April all the way up to the 30th of April. So I guess we can go ahead and create some daily statistics as well for the month of April, and for any month basically, because this rainfall data you can download them quite easily using one of the websites where you can download the Chirp's rainfall data. So I guess I'll see you guys in the next one. So until then, take care guys.